carbon cycle and ecology. Um, there are all sorts of nutrient cycles that happen in our ecosystems. And a model of that is what the cycle is, right? We're showing various parts of an ecosystem, sometimes living, sometimes non-living, and we're showing how carbon or water or nitrogen or phosphorus moves within that system. And there's various processes that cause them to move, right? So if we're looking at a plant, might take in the carbon through photosynthesis, and then the carbon might that plant might do cell respiration because plants do both photosynthesis and cell respiration. The plant might do cell respiration immediately and put that carbon right back out into the atmosphere. We would want to be able to depict that in our model and show that carbon could go from the atmosphere into the plant and from the plant back into the atmosphere. The plant also might take that carbon and put it into its sugar, and it might keep that sugar there uh, and not use it in cell respiration. And so it might become kind of like a starch, a storage sugar. Maybe this is corn we're eating, right? And the corn, or the corn that's been generated through photosynthesis, then that corn maybe gets fed to a human. And the human might do cell respiration with that, and then it gets released. Or the human might take that carbon and put it into another one of its molecules, right? Might store it as fat, for example. Or the human might decide, you know what, corn's good, bacon's better. I'm going to not eat the corn. I'm going to feed the corn to my pig. And the pig might take that glucose molecule that's in the corn kernel and turn it back into carbon dioxide for the atmosphere through cell respiration. Or the pig might make it part of its body. And so you get the idea, right, that we can see how carbon can move into and out of the ecosystem. We want to model that by showing those various reservoirs or portions of the ecosystem, and we want to explain how it can move, right, how it goes through that. And so there's lots of different ways that carbon can move through the ecosystem. One of the big long-term reservoirs of carbon in the carbon cycle is the movement of carbon into what we call fossil fuels. So this typically happens, like for example, in for coal, right? We have swampy areas that have sedimentation take place and bury the swampy material, the dead decaying plants, right? And these swamps weren't just around for a little bit of time, they're around for millions of years. So you imagine a really thick layer of swamp gets covered by sediment maybe over the course of a decade. And then it keeps piling up, piling up. Well, they're now trapped, right? They can't decompose as they normally would. And then millions of years of erosion happens, and we get tremendous amounts of rock or sediment piled up on top of it. When you get hundreds of feet of rock and sediment sitting on top of this coal bed, or this bed of dead material, dead plant material, that puts an immense amount of heat and pressure on them, and that can cause chemical changes that fossilize this plant-like material into coal. And that is one of the main reservoirs of carbon. We can also have oil generated in a similar way, natural gas. It just kind of depends on some of the specifics of how it ends up in both, like, is it what type of material was it when it was alive, right? Uh, and what specific happened in the processes of the deposition and fossilization. So, but the general idea is not too hard to grasp, right? That sedimentation buries these organic molecules, and these organic molecules then get fossilized over time. Well, one of the things that humans have done over the last few centuries is we've taken a lot of what would have been trapped in the earth as fossil fuels, and we have consumed them. And when we burn those fossil fuels, carbon dioxide gets released in the atmosphere. And when we look at the data, I went through this in my lecture here on climate change. When we go through the data, there's really strong evidence that there is a warming of the planet. And when we look at the potential causes for that, it's quite clear that the thing that's increasing are greenhouse gases. And greenhouse gases we know can cause that kind of warming. When we look at uh, how our planet's orbit is changing, the amount of energy the sun is giving off, none of those seem to explain the changes that we've seen. We have measurements for all of these things that we know can change our planet's temperature. And the only one that seems to really match the change of our temperature well is the increase of these greenhouse gases. And some of those greenhouse gases would be like water molecules, right? Evaporated water is actually a really strong greenhouse gas. Carbon dioxide and then methane are three key greenhouse gases. Nitrous oxide could do a bit as well. Our activities are increasing those. And so what effect does a changing climate have on that? That's what some of these videos went through and showed us, right? We can impact the sex determination of turtles, for example, which are impacted by temperature. We can impact the coral reefs with acidification that's due to the warming. And so these have massive impacts on the ecosystems of the world and specific species of the world. And so it's really hard to know where these ripple effects will end as we impact the climate as we have. Okay, really quick, I want to go through our types of ecological relationships. So we have mutualism, which is when two organisms interact long-term and both benefit from that interaction. So a classic example of that might be like the ants and the acacia tree, right? The ants eat the proteins that the acacia tree secretes, so they're benefiting. And the acacia tree, if it has a herbivore come and try and eat from its leaves, the ants attack that herbivore, and so both benefit from that interaction. Next, we have competition. This is when both organisms are harmed by that interaction. And so this is when they're both trying to fill the same niche, and as the result of this competition, right, maybe one has to reduce its reproductive potential in order to grow more, whereas others might get rid of growing and focus on reproduction, and so they kind of beat each other out, or both are harmed by their interaction. Predation is kind of a short-term interaction, but it's where one benefits and the other is harmed, obviously through a eating of one versus the other. Parasitism is a long-term positive and negative, where it doesn't typically come with immediate death of the host. And then we have commensalism, where one benefits and the other is kind of neutral. And so those are going to be some pretty basic interactions that happen in ecosystems, not too difficult to get those definitions down.